Hello and welcome back to SQA Higher Maths, applying differential calculus. So looking at maximum and minimum values within a closed interval. So again, we need to find the turning points. And then after that, we need to look at each end of the interval and see if the points at the end of the interval are any higher or lower than the turning points. So let's go into an example. So a function f is defined between -1 and 4 by f of x. Find the maximum and minimum value of f of x. So first step, find the stationary points. Again, as I mentioned in the first video there, guys, go back and have a look at lesson 7 in the differentiation playlist if you need to refresh your stationary point knowledge. So we differentiate. First of all, we then set that equal to 0 for stationary points. Remember to make that statement. We must make that statement. So then we're going to solve to find out the two values of x here. So take out a common factor if possible. Factorize the quadratic expression. Solve for x. Remember the 2 at the front, that is just a 2. If it said 2x at the front, then x could be 0. But it's just 2, so we don't get a solution from here because it's just a 2. So 3x plus 1 equals 0, or x minus 2 equals 0. So that gives our values of x. And then find the y coordinates to go with those x coordinates. How do I find the y coordinates? I substitute into y equals. Remember, guys, if you're a little bit lost at the moment, go back, lesson 7 on the differentiation playlist, have a look at stationary points. This is a very common exam question. You do need to be able to do this in your sleep, so please have a look at it if you need to. So substitute in x equals -1/3 and x equals 2 to find the two stationary points. We now need to determine if they are maximum or minimum values. But remember, because we were all listening in class when I was going through it, this is a cubic with a positive coefficient of x. So we know it's going to start down here, go up, fall down, and go up again. Okay, so I know that the first point is going to be a maximum and the second point is going to be a minimum. Okay, so our nature table should confirm that, which if we have a look, it does indeed. The first point is a maximum, the second point is a minimum turning point. So how do we go about doing that? So -1/3, need to look at a number either side of -1/3. So before -1/3, we could pick -1. We substitute -1 in for x, and we end up with 2 multiplied by a negative multiplied by a negative, which gives a positive value for the gradient. Remember, we're finding out the sign of the gradient before -1/3, so we're going to have a positive gradient, so it's going to increase. Substitute -1/3 into this first bracket gives 0. So a gradient of 0 is flat, and then a number after -1/3, but remember, guys, we need to look before 2. Okay, we couldn't pick a number after 2 here, so you've always got to be aware of the x coordinates of your two stationary points. You're looking in between. Okay. So here's the final answer. So I want to be looking somewhere between here and here to find out what the graph's doing, which is falling. I couldn't pick, say, 3 or 4, x equals 3 or x equals 4 to look at, because that's past the second turning point. So sometimes these points are quite close together. So be aware that you've got to pick a number before the second turning point. Okay, so I'm just going to pick 0 here. So it'll be 2 times a positive times a negative, which gives a negative gradient. On this nature table, again, I could pick 0 here, which will give a negative again. And when I substitute 2 into the second bracket, we get 0, and then a number greater than 2, so let's just pick 3. So it'll be 2 times a positive times a positive. So positive gradient, so the curve's increasing after 2. So we've got a maximum and a minimum. Right, so as we said at the start, we also need to look at each end. So we need to consider when x is -1 and when x is 4. So that gives these values. Okay, so substitute in and evaluate. So make a sketch and just see when the curve is at its highest and lowest point. So the maximum value is not the same as the maximum turning point. The maximum value is 33 when x equals 4. The minimum value is -11 when x equals 2.